I, Rahul, and Chirag are now going to be teaching you integral calculus. So, Chirag, tell our students, what are we going to be studying in integral calculus as such?
Okay, basically you must have learned about derivatives where you differentiate a function. When we get that function, we try to get the function from which we differentiate a function and get another function. From that function, if we try to get the earlier function back, that is what is called integration.
Alright, so that's fairly simple. So that's what we're going to be studying.
Considered fairly simple is not the right word. Many people find it very difficult.
Oh.
So some people find it very challenging. Challenging is the right word, I'll say. Difficult makes you go away from it. Rather, you should call it challenging and accept the challenges and move forward.
So, with regards to the approach that we should have towards this chapter, what's the kind of mentality the student should work with, and what kind of mistakes should we avoid?
Mistakes as such, there's this problem with multiplication of constants as such, because people usually avoid constants. They're more concerned about evaluating the integral. But when you look at the MCQ questions, most of them are going to be about what are the constants, which are multiplied with the functions that you're getting as answers.
Alright.
So a small mistake can reduce your work to zero.
Okay.
So that is
we
what
should be careful about constants.
Right.
Alright. That's the primary thing we need to worry about, other than getting the hang of integral calculus as such, which itself will involve copious amounts of practice as such, right? Now, tell me, what did you find interesting about integral calculus? Like, I think it's a fairly fascinating field, regardless of it being challenging as such, and it has applications across technology and science as such. But what did you particularly like about it?
Okay, like if you look at the area of circle, right, there's a very complicated method of getting the area. But like if you use integral calculus, you can get it pretty easily. And in fact, if you look at all the if you look into electrostatics, magnetic fields, all of them require this integral calculus. You see, the force changes with distance. We have a function which is changing with distance, we need integral calculus. Everything that's changing with distance.
Okay, so anything that is dependent upon another quantity and is going to be multiplied by something else, we will have to solve it using integral calculus.
Definitely.
So as you can see, it's basically a tool that you need to have in your toolkit before you can start creating anything else as such. It has applications in physics, in chemistry, and obviously in mathematics as such. So the fundamentals of this chapter are something that will stay with you and will be important to you regardless of what chapter you're studying, regardless of what field you're studying in, whether it's biology, whether it's chemistry, whether it's a field of engineering, and which is why I think it's really, really important to study this, right? So let's dive into the questions and let's see how Chirag teaches us this topic. What do you say?
I'll be up to the challenge, I believe.
Alright, so Chirag's going to be up to the challenge.